Section 4.2, Properties of Logarithms. Part 1, Common and Natural Logarithms. Common logarithms. A common log is a logarithm with base 10. And we can write that without the 10. The 10 would be implied if we just write logx. That means log base 10 of x. Let's evaluate the following common log. So log of 100. We could write that as log base 10 of 100, which means 10 to what power equals 100. And since 10 to the second power equals 100, log of 100 equals 2. How about this one? Log of the cube root of 10 to the 7th power. I'm going to rewrite this as log of 10 to the 7/3 power. So if we write it with that exponent instead of the radical, we can easily see that the answer to this one is 7/3. So 10 to what power equals 10 to the 7/3? That would be 7/3. Log of 0.00001. That means 10 to what power is 0.00001. To figure that power out, I could just pretend the decimal was right here and see how many times it moved. 1, 2, 3, 4, 5, and it moved to the left. So 10 to the -5th power is 0.00001. How about the natural log? Natural log is another common logarithm that we use, but we don't call it the common log. We call it a log base e, and it's called the natural log because it shows up in nature often. We can write this as just ln. So log base e of x is ln x. So what is e? E is the value of 1 plus 1 over m to the m power as m gets infinitely large. So what that means is m gets bigger and bigger and bigger. The value of 1 plus 1 over m to the mth power gets closer and closer to e. E is an irrational number, so we're never going to get it written out exactly because the decimal will go on forever without repeating. So here's a chart that kind of gives you an idea of what it might be. So if m is 1, we have 1 plus 1 over 1 to the first power, that's just 2. But if m is 100, we get 2.70481. If n is 10,000, we get 2.71815. If n is 1 million, we're even closer, 2.71828. This is about what your calculator would show. If in your calculator you find the e to the x button and do e to the first power, it'll give you more decimals than that, more decimal points. But that'll give you a better idea of what e is equal to. Again, it is an irrational number, so the numbers go on forever without repeating. But about 2.718 is pretty close. Let's graph f of x equals e to the x. So we're going to plug in some values for x and approximate what e to the x is. So if x equals -2, then y is e to the -2, which is about 0.135, and you can just find that on your calculator. So the point would be -2 e to the -2. So on our graph, we'll do -2 and about 0.1, which it looks like it's about right there. E to the -1st power, if we do that one on the calculator, I get approximately 0.368. So our point -1, e to the -1, so -1 about 0.36, and I'm approximating for the graph. E to the 0 is just 1, so we have that 0.01. E to the first power is about 2.718, and that 0.0e. So e to the 0 is 1. I didn't graph that one yet. E to the first power, about 2.7. And e squared, if we look at on the calculator to approximate that, we get approximately 7.389. So the 0.2 e squared, we'll graph 2 and about 7.3, so about here. And it looks very similar to what 2 to the x and 3 to the x look like. It should be about halfway between, not quite halfway, but between 2 to the x and 3 to the x. How about this one, the natural log of x? So let's try that. The natural log of x will be the inverse of e to the x because the natural log of x is a log base e of x. So if I plug in some values for y, say -2. If I say y is -2, I have negative 2 is the natural log of x. That means e to the negative 2 equals x. So that would be e to the negative 2 equals x. So my point, e to the negative 2, negative 2. And we could do that with all of them. So e to the negative 1, negative 1. E to the 0, which is 1, 0. E to the 1, 1. And e squared, 2. And this is, again, the inverse of what we had here. So e to the negative 2 was about 0.135. So to graph the point e to the negative 2, we have about 0.135, negative 2. E to the negative 1 we found was 0.368, so about 0.368, negative 1, 1, 0, e to the first 1, and e squared kind of is off the graph. E squared was 7 point something. But we know the basic shape of a logarithmic function, and this is going to look just the same as all the other ones, except for just slightly different, but the same shape, slightly different spots on the graph. So they are inverse functions, like we said. So if this is e to the x, and this is natural log of x, we can see that the two graphs are symmetric about this line, y equals x, because they are symmetric.